Hello everyone and welcome to Mathematics, which helps you to practice the habit of completing a question a day in mathematics. For this video, we'll focus on Chapter 3, Integration, and let's aim ourselves to learn two things from this video. Alright, so I'll let you have a few seconds to go through the question first. The things we can highlight is there are two curves and one of the curves equation it is not given. And in diagram 3, we have these three regions. So for the details, I'll explain in part B. So in part A, they're telling us to find the coordinates of A, and point A is the y-intercept of these two curves. So we know that for every y-intercept, their x-coordinate is 0. So you can sub this value inside here. So once we sub, we found out that there are two answers of y, because when we move square to the other side, it will produce a positive answer and a negative answer. So it will be y equals to 1 and y equals to minus 1. So since point A is above the x-axis, so we need to reject this value. But this value is actually another intercept of this curve, which is here. So we actually found out its value, which is negative 1. And for part B, they give us this equation and are telling us to find the area of the shaded region for both P and Q in terms of M. So our answer must have M, and it comes from here. So this is the first aim of this video, which is to learn how to use integration to find the area. So we can split this question into two parts: find the area for P and then find the area for Q. For region P, you notice that it is bounded by two lines. One is this curve, and one is the y-axis. So this is our shape of the region. And if you look from the right side, you can see that this region P is under this curve. So to find areas under any curve, we need to use integration. So since this area is bounded by the y-axis, so I'll put y outside of the integral. So this means we need to integrate x. So this x, we can find it from this equation, so we need to rearrange a bit. And since we're integrating in terms of y, for the limits, we can use the y-axis values. So here, using the answers from part A, we can use these as our limits. So from negative 1 to 1. And for region Q, we can use a way that we learned from the previous videos, which is to select the big shape and minus out the unimportant parts. So our big shape will be the rectangle and minus out this white shape and the region R. So to find the area of the rectangle will be easy. This will be 2 and this will be 3, so we multiply 2 and 3. So to find the area of the white region is actually the same case as we find region P. Because if you look from the left side, you can see that this region is actually under the same curve. So we can integrate this equation again, but the limits will be different because it starts with 1 and ends with 3. And for region R, by looking down, we can see that it is the area under this y equals to f of x curve. And also by looking down, you can see that it is bounded by the x-axis, which is different from the previous two regions. Okay, but since this one does not have a equation, it's okay. We just write out the expression first. So it's bounded by the x-axis, so we need to put dx, which means we need to integrate y. So y here will be f of x. Since we're integrating in terms of x, we need to use the limits from the x-axis only. So here it starts from 0 and ends with 2. So these will be our limits. But you may notice this actually looks familiar because by looking back to our question, this is m. So we don't have to use this anymore. We can just substitute this to m. So when we integrate, we can move these numbers out because it's divided by y. And we need to integrate the things inside. So here, remember to add 1 to the power and divide with the new power. And the 1, we can just add a y. Then later, remember, we need to sub these two values and minus the values together. But here is the incorrect answer. So I'll let you all to have 5 seconds to think where we did wrong. And the answer is this region. Because remember, when there is a area, the right side of the y-axis, it will be positive. If it's the left side of the y-axis, it will be negative. So if you notice the blue answer, it is negative, which is wrong because area does not have a negative value. So here, since we know that when we calculate will be negative, we need to add a modulus to this part. So our correct answer would be 14/3 minus m. Alright, moving on to part C, we need to find the volume generated when this region R rotates around the x-axis at 360 degrees. So our answer need to be in terms of pi, meaning we don't change the pi to a number. And they've given us this clue, which is the area of region R is this equation. So this is the second aim of this video. We need to learn how to use integration to find volume generated. So here there are two problems. One, if we want to find volume generated, we need to have an equation. But here our equation is unknown, which is f of x. And the second problem is, they've given us this area of cross section, but we don't know how to use it to find the volume generated. So before we solve this question, let us understand the formula that we always use to find volume generated. So we need to tackle two things. One, we need to understand where does this come from. Secondly is, what does the things inside the formula represent? So the original source for this formula is actually the formula of volume of cylinder, which is pi r square h. Right, why is it so? Because let's say we extract one small rectangle from this region R, and we rotate this rectangle around the x-axis 360 degrees, as you can see in this video. So if you notice, this rectangle will rotate to become a cylinder. And you might ask a follow-up question, which is, why is here R but here is y, and why is here h but here is dx, right? The reason is because they're using the measurements in this xy plane. So let's say we want to find the radius, which is this thing. So they assume the y coordinate is y and the center is in 0. So to find the radius, we just y minus 0, which is y. And for the height would be here. So they are finding the differences between these two coordinates. So we can denote this as dx, the differences between two x coordinates. And the third question you may ask is, wait, why do we need this integral? Right, remember, this example is only one small rectangle from the region. So here we actually have a lot of rectangles. So to sum all these rectangles up, we need to integrate pi y squared in terms of dx. And another thing is, this pi r squared is actually the area of a circle, and this h is actually the height. So if we multiply these two things together, it will be the volume. So by relating this concept to our equation, we can see that it gives us the area, which is this. So this equation would be our pi r squared, or would be our pi y squared. And the dx, we can remain it. So now, to find the volume generated, we need to integrate this equation in terms of x. Since we need to integrate in terms of dx, our limits, we need to follow the x-axis. So we can use back the same limits as part B. So here will be 0 and 2. And our answer would be 94/15 pi units cubed. And with that, we have completed today's question. Alright, here are the aims of this video. We need to learn how to use integration to find area and the volume generated, and here are our take-home points. So to find the area, we can use a technique, which is to find the big shape and minus out the unnecessary small parts. And sometimes for area, we need to learn how to find area under the curve, which is we need to use integration. Sometimes we need to find triangle, rectangle, and trapezium area to find the area of shaded region that we want. And to find the volume, we also learned that for the formula, it splits into two parts. The pi y square will be the area and dx will be height. So we multiply these two values together, it will be our volume. So here's the answer scheme for this question, and hopefully you have learned something new from this video. So if you feel this video is beneficial to you, please leave a like, subscribe, and share it to your friends and classmates. So I'll see you all in the next video. Bye bye.